The topic is calculating a definite integral using Riemann sum. We have the definition right here, so all we need to do is this second example. We did one example, so for the second example we need to find integral of x from 3 to 7 dx. So first of all, we know this is my f of x, right? So let's start. We always start by finding delta x, and this is the formula for delta x. Delta x is equal to b minus a over n. Remember, b is the upper limit. This is my b, and then a is the lower limit, which is 3. So this is going to be equal 7 minus 3 over n, which means delta x is equal 4 over n. So this is the first part. After that, we need to find, so far we found this, delta x. After that, we need to find f of xi. How do we find f of xi? We need to first find what is x sub I. X sub I, by definition, it's right here, it's equal a plus I delta x, which means xi is equal, a happens to be the lower limit is 3 plus I, and delta x, we just found it, which is 4 over n. Now I need to find f of x sub I, which is, what does it mean? First of all, we need to know what is f of x. F of x is right here. F of x is equal x. F of any input is just itself, that input. So x, whatever your input is, that would be your output. So f of xi means f of 3 plus 4 over ni, which is equal to 3 plus 4 over ni. Alright, that's f of xi. Now let's do the integral. Integral from 3 to 7 of x dx is equal, by definition, a limit as n go to infinity, definition is right here, of the sum from I equal 1 to n of f of xi, let me write it, f of xi delta x, which is a limit as n go to infinity of the sum from I equal 1 to n. F of xi, we said it's 3 plus 4 over ni, and delta x is 4 over n. So far, so good. Now this is going to be equal to limit as n go to infinity. I'm going to distribute 4 over n, so that's 3 times 4 is 12. So 12 over n plus 4 times 4 is 16, n times n is n squared, so 16 over n squared I. And we want the sum of this from I equal 1 to n. Now we have to use the properties of sum. The properties of sum says this is going to be equal limit as n goes to infinity of the sum from I equal 1 to n of 12 over n plus the sum from I equal 1 to n of 16 over n squared I. One more step. This is going to be equal limit as n go to infinity of the sum of 12 over n from I equal 1 to n plus, this is considered this constant. In expression that doesn't have an I, it's considered a constant, so 16 over n squared sigma of I equal 1 to n of I. Alright, now this is going to be equal limit as n go to infinity. Now since 12 over n is a constant, sum from I equal 1 to n, let me write the formula here, sigma of a constant c from I equal 1 to n is the same thing as mc. So my c happens to be 12 over n. So this is going to be n times c. c is 12 over n. Plus 16 over n squared, and sigma of I wrote the formula, it's right here. It's n times n plus 1 everything over 2. Now we need to do some simplifying, and this goes with this one. So this is going to be equal limit as n goes to infinity of 12 plus, I'm going to distribute the n. This is going to be equal 16 and multiply times, I'm going to distribute the n first, so it's n squared. N times 1 is n divided by, and then n squared times 2 is 2n squared. Now this is going to be equal to a limit as n go to infinity of 12 plus 16n squared plus 16n over 2n squared as n go to infinity, which is equal to 12 plus, limit as n go to infinity of this function, since the degree is the same, we always get 16 over 2. The coefficient of n squared divided by the coefficient of the denominator, same thing, so 16 over 2, which is equal to 12 plus 8, which is 20, and we're done.